So can I start now?
Yes, sir.
Okay, so welcome to my presentation on atmosphere. In the first class, we have discussed about the subject matters of the course atmospheric science. Today, we are formally start our first chapter on atmosphere. Although you have a substantial primary knowledge on the atmosphere in your geography class, if you can remember that, but in the same in your syllabus the same thing is in here also, but I think that would not be sufficient for this course. So what we will do, that we are going to discuss about the few topics which is you have already learned in your geography class. So I termed it as a recap, so you can understand and you can remember the process of the atmospheric phenomena. You can also remember the different sets of atmospheric characteristics, how it has been originated, what are the different classification of different layers. You can understand that. But what I wanted to do that later of this chapter, which I wanted to include in here, that we need to know the details of the atmosphere. For example, we have the knowledge of the composition of atmosphere. So now what will we do? We are trying to go in depth knowledge on each of the gases, because each of the gases is very much significant for in case of atmospheric phenomena. Among them, some are permanent gases, some are variable gases. So we will more interested about the variable gases. So we'll go for in details of that discussion. Uh, Again, we wanted to include about the few phenomena which it will be started from here, and maybe it will last long in other courses also. We'll discuss about the greenhouse gases, because these are the gases which we termed as flexible gases, or which we termed as variable gases in the composition. So we'll discuss about their contribution on greenhouse effect. We do also discuss about the ozone layer depletion. How basically we have discussed that things in a stratosphere. So now we are going to discuss little bit more about the process, and few air pollutants, which you can get many description of different other subjects, air pollution and air pollution management and different other environmental management. You can get that. But in this case, what we will do, we will try to combine it together with the formation of the atmosphere. uh, and at the last of this chapter, we will also discuss about the condition of the other atmosphere, atmosphere of the other planets, and that particular cases we will try to focus on why the atmosphere of Earth's surface is much more suitable for living. Sorry. And then you can also, we will also discuss about little bit about a procedure of radiosonde. Radiosonde is a process of to get the information about the atmosphere through using some specific instrument with balloons. So we'll discuss about that. So if we discuss about that things, first of all, I don't know who wanted to enter in again and again but could not. Sorry. So before I starting the details chapter, we should go for a recap, a quick recap. I am going to be fluently to understand, because I thought that you have already know that things. So that's why I'm going to be a little bit more swiftly for those topics which has been discussed in your earlier courses. So this was the first slide in your other courses. So how does the atmosphere look like from the space? How does it look like? You see the thin envelope around the world, around the Earth's surface. If it is you are from outside if you are outside the Earth, that means from the space, you can see the thin envelope by the side of these things, little hazy portion of the blue color, and little bit dark outside, and inside there is light. That means this is the area where the more amount of the gases can be found. So this is the Earth surface, which can be seen from the outside the space. So what is the significance of this of this atmosphere? You know that without the atmosphere we cannot think about anything in this atmosphere. Atmosphere, as we described, this is a blanket of the thin blanket of the air substances. What does air means? Air is a composition of many gases. That is air, and that is surroundings all over the world. Maybe somewhere it is much more densitized, somewhere it will be less densitized, but all over the world this is termed as the air, atmosphere. And the Earth, without the atmosphere we cannot think anything. As I said, we cannot think about any water bodies, we cannot think about any living organisms, we cannot think about anything. For example, I'm talking with you, so without the Earth surface, without the atmosphere, you cannot hear me, I cannot hear from you. Without the Earth surface, there will be no color, there will be no clouds. So all things will be lost actually. And obviously the breathing system which we are taking now at every moment, the oxygen from the atmosphere, we cannot do that. So actually we cannot live, we cannot think about anything without atmosphere. And as we said, air is a tasteless, odorless, and most of the time it is invisible. We cannot see it. We can only see it if there is high amount of the pollution is there, and it can only be felt by a gesture, to understand it. Or we can weight it. We can understand it, that there is air in there. And the maximum amount of the gases which we normally say that air, which can be found at the lower level of the atmosphere, we can find it on the ground surface. Origin of the atmosphere included from the long history ago, when the galaxies has been originated up. So background of the atmosphere, we can say that what is the position of the planet from the particular stars. So our star is our sun. So there are billions of suns in these galaxies, and there are billions of galaxies in this universe. And these galaxies, Milky Way is one of them, and stars remain in a positions at the side of this Milky Way galaxy. And we have our own stars, which is termed as sun. This sun has 8 planets. And these planets has moving around the sun. And with these planets, we have also different other celestial bodies. We have comets, asteroids. We have meteors, and sometimes we have also found information about the dwarf planets. All this comprises of our solar system. Why it is important to atmosphere? Because each of the planets that have the atmosphere, but not the same amount of the gases, and not the same types of gases also. So that's why gases can be different, amount can be different, but the process is process of being having percentage of different gases will be different. Another important thing is the distance from the particular planets from their sun or from their star is also very important, because sunlight or the light which is coming from the stars, it needs to travel a long distance. And during this distance, if there are some atmosphere in there, then they need to travel a lot, and then they don't reach to the area where it is a long kilometer away. So that particular type of planets, which is very cool because of the distance, that particular type of planets is very cool because of their different sets of atmosphere. We'll also see different types of atmosphere later of this chapter. So why it is important? Because sometimes this atmosphere give us the opportunity to have a comfortable environment to live in. Comfortable environment means the amount of the environmental factors such as temperature, sunshine, humidity that should be in favor of the living beings, in favor of the human beings. In case of this world, that means what we say Earth surface, this Earth surface, we normally do experience about a very gentle condition and comfortable environment. Normally it should be 15 degrees centigrade in an average, although the temperature varies a large from some areas, some desert areas in the noon time, maybe it is more than the 50 degrees centigrade. On the other hand, in Antarctica, in a cold night, it can be minus 85 degrees centigrade. So temperature is varied depending on different location, but the average temperature should be 15 degrees centigrade. Why we say that? We say that because if it is not 15 degrees centigrade, that means there are the energy which coming from the sun that remain in the atmosphere, that remain inside the atmosphere, that remain inside the earth, or maybe the more energy has been escaped from this earth surface. So the balance which is governed by this atmosphere, it is very important. So this is another significance of the atmosphere. The radiation which is coming and go back, that should be in a positions so that it should be comfortable for the living beings. This is the another significance of the atmosphere. Now the vertical extent and decompositions, how the earth atmosphere extends from top to down. So normally we do expect that most of the gases is remaining in the lower atmosphere. That means in about 99% of the atmospheric gaseous composition should be under 30 kilometers in near to the earth surface. Sorry. And another important thing is how long it extends. So in a word, there is no limit, because if you go to a 400 kilometers away from the top, from the earth surface, maybe you can also get some, gases, but the concentration of gases will be very limited. Maybe a couple of molecules you can find, but that is not significant. So significant thing is most of the cases, the gases are remaining under the 30 kilometer from the earth surface. This is very important. Few other special gases which remaining in the atmosphere but in a very lower condition, lower concentration is also very important. Such gases are, for example, ozone. Although the concentration is very low in the atmosphere, it is much more important, because that also a media that protect the UV rays, ultraviolet rays from the sun. So that is different things. But generally, we do expect most of the gases under the lower atmosphere. This I am not going to discuss about this table because you have already known about the table. What I wanted to give you a notion that permanent gases in the left side, they are remain as a very constant positions all the time. Constant doesn't mean that they don't react. For example, oxygen is always changing, but the balance is very much constant for in case of oxygen. We'll see that in the lower portion, each of the discussions. So oxygen, to generate and to reduce the oxygen is nearly same. That's why the balance is very constant. On the other hand, we are interested about the variable of gases. Atmospheric science, in the atmospheric science, if you wanted to be an expert on different phenomena of gases, different phenomena of the gases, if you wanted to be interested about that things, for example, if you wanted to know the changes of the water vapor or carbon dioxide or methane or anything, you wanted to be an expert of that thing, so you need to focus on this. Even the percentage is very much nominal. Can you see that the percentage of each of the variable gases? It is too tiny. For example, in case of carbon dioxide, which is the main culprit of the for the climate change, So that carbon dioxide is, the percentage is very much nominal. You can see 0.038%. That means less than 0.1% also. But this carbon dioxide is too much important for our climate change impact. So we wanted to focus on this. So in your exam, if it is coming, that what is the significance of variable gases in atmospheric composition, then you should have to explain this. For example, you can explain as a water vapor. If you go for a water vapor, I will discuss it elaborately later also, but just for example, water vapor is a very important aspect. So when the sunlight fall on that water vapor, what does water vapor means? Most of the cases we say this is cloud. So when the sunlight fall, it can be bounced back. It go away on the top of the surface of the cloud. So radiation come without penetrating to the atmosphere, it go away. So this is the importance of atmosphere. So radiation cannot come. On the other hand, when it come inside the surface, then it changes to a different wavelength. It turns to heat energy, and this heat energy wanted to go back, and then again that can be obstacled by these water vapor. So variable gases has much more importance on different aspects. You can explain such things as a carbon dioxide, methane, or nitrous oxide, even for ozone. So that's why we are more interested about the variable gases. So now how the atmosphere has been originated. So this is a very interesting question also before. Just to recap, our atmosphere has been originated from long ago. The first atmosphere came into shape in 4.6 billion years ago. And that time, most abundant gas was hydrogen and helium. We know that. And such components, which is made up of with hydrogen and hydrogen, that means the molecules of the hydrogen, they come together with the compound of carbon, nitrogen, and many others, so that they can be mixed up and they produce some compounds. Later, some scientists believe that the earlier atmosphere, in the first atmosphere, that has been escaped into the atmosphere because the Earth's surfaces was too much heated up that time. So this is on sorts of idea, not established, but there are some ideas. We can also assume that most of the cases, as nitrogen has been enormous and they are inactive in a positions, so that nitrogen remain for long time in the atmosphere. On the other hand, the oxygen which has been produced from different significant chemical reactions, they have been come up with the hydrogen molecule to come together, produce a water vapor. That means H2O, and H2O again can be splitted up due to photo dissociation reaction. That means sunlight fall on it on the top of the surface, and then it can be just break down, and this oxygen remain for a long time because the hydrogen has been escaped due to lighter weight. So remaining oxygen and nitrogen was very much practical at that time. Rather than these, the other types of permanent gases, if you see that, argon, neon, helium, xenon, these are the gases we say inert gases, and inert gases doesn't react with one another. So due to production of different natural sources or artificial sources, these gases remaining for long time in the air. They don't react normally. So that's why they remain also there. On the other hand, the variable gases, they can be changed. They can be changed due to many activities. Due to natural causes, due to artificial causes, they can be changed. And that they are also very important. Why they are important, I discussed some of them and we'll discuss later also. So to understand it, to understand how this has been originated, we can say that only the oxygen percentage and nitrogen percentage, how it came into the shape. This is important. Now think about the different layers, how we can divide it. We can divide it in different layers based on different characteristics of the atmosphere. We can of the gases. The gases have different sets of characteristics. So we can divide it in on the variation of the temperature, because in different layers we can get different temperature. We can divide it in on the basis of the gaseous compositions, because in the down, as I said, 90%, 99% gases can be found in the lower atmosphere. So we can divide it into two parts. We can also have some other parts. For example, in the stratosphere, we have huge number of the ozone. On the other hand, if you go top or down, there is less amount of the ozone. So depending on the gaseous composition, we can divide it. We can also divide it on the basis of the electrical properties. Some of the areas which has been electrically charged, basically the air is neutral. That means the gaseous composition is neutral in a positions. But sometimes it can be electrified. That means the electrons on the molecules, they can be changed. Sometimes they can be loose, sometimes they can be gained from other sorts of gases, and they can be electrical charged particles. That time we can also divide it into based on their electrical properties. Now the important two things is one is air pressure, another is density, and they both are related. If you have more density, then your pressure will be more, and if you have less density, then your pressure will be less. And depending on the density, you can also it can be also change the weight of a particular area. That means the column of the air, which started from the top of the surface to the all through the atmosphere, it has a weight, and that weight can be changed depending upon the positions where you are now. So your position, if you're at this mean sea level, then your weight should be 14.7 pounds. That means your weight, not, it is the weight of 1 inch of the cross section area of the air. So think about yourself, how many square centimeters you have on the top of your surface on your body. So that much multiply with 14.7 pounds is acting on you. And now you are traveling to the top, maybe 1 kilometer up, then it will be reduced, because the weight is a production of what is a calculation of mass and gravity multiplication. So mass will not be changed, mass will be same, and 1 kilometer above your mass will be same, but your gravity will be changed, and due to lower amount of the gravity, your weight will also be less. So that's it, depend on these two. Another thing is, when density is important thing, density come up with a term with volume. So in a specific mass, if you divided that specific mass with the volume, then it should be around 1.2 kilograms in per cubic meter. That means if you have 1 meter height, 1 meter length, and 1 meter wide of area, if you just measure it on the top of the near the sea level, if you measure it, if you weight it, you can get 1.2 kilograms of air. So this means air, the amount of the composition of the air is different in the near sea level, and if you go to the any high mountains or top of the sky, you will get less amount of the air masses in there. So density also will be changed. Similarly, the pressure is also very important thing. Pressure means force by area, how much force active on a particular area. So force is force divided by area, it denotes the pressure, and pressure is also important to understand in a particular positions what amount of the pressure you are gained. So in the top of the at the mean sea level, we get an atmospheric pressure of 1013 millibar, and the pressure will be decreased if you go to the higher positions. So generally 1 millibar has been reduced in part 10 meter. If you go 10 meter above, then 1 millibar will be dropped down. Now if you go to the 1 kilometer above, then 100 millibar will be reduced. Similarly, the other characteristics will also be changed. So depending on your positions, this is very important, because if you lose your pressure, this pressure has a significant variation, significance on different atmospheric phenomena. Such phenomena included the cyclones, tornadoes, and many others. So if your pressure varies from the inside and outside of a certain cyclones or tornadoes, the more the pressure is, the capacity or the force is will be more, because of the change variation of the changes, and your circulation of the wind with water particles will also be more, and that depends on many other characteristics. So pressure is also very important in case of our atmospheric science. Can you understand me? Hello?
Yes, sir.
Yes, sir.
Okay,
Yes,
if
sir.
you if you
Yes,
cannot
sir.
understand, if you cannot understand, just let me know, or you can ask me question anytime. I'm just going very quick because you already known these things. No, in your geography class, I have discussed all these things. Just a recap. I just shared these things. Okay, and then we will go for a little bit slower in later of this chapter. But still, if you have any question, you can ask me. This is the condition of the air density and air pressure. You see, both of the cases, the graph is in a very increasing positions in the lower atmosphere. If you say this is our, if you just think about in 1 inch of air, this is, if you just measure it, it is 14.7 pounds. In the top of the atmosphere, it will be very less. You see in the top of the atmosphere, there are few molecules in here. So number of molecules will be less, and so do we have much more molecules under the ground. If you see these positions, most of the cases, the ground positions, we have much more molecules. This will also allow the pressure, more about the pressure in here. Now come to the different subdivisions, based on the altitudes, based on the temperature and altitudes. We can divide it in 4 categories, 4 layers, not categories, 4 layers. One is troposphere, 0 to 11 kilometer, 11 to 48 stratosphere, 48 to 85 mesosphere, and thermosphere is above the 85 kilometers. Troposphere is the lower portion, which is starting from our ground, and normally the air is well stirred up because of this is the positions where we get maximum number of the gaseous compositions. Sometimes this is also a characteristic that descending air currents. So the air currents is in the descending mode rather than ascending. So above 11 kilometer, it is within this limit. Normally our temperature is in a decreasing rate. That means 0 to 11 kilometer. If you wanted to go from the ground to a higher place, your temperature will be loose, and that temperature decrease happening in a positions that if you go 1 kilometer above, you will lose 6.5 degrees centigrade. And upper layer of the troposphere, we say tropopause, and even we say this is 11 kilometer, but actually there is no sharp boundary of each of the layer, because this is an imaginary line. We just only think about this 11 kilometer based on the characteristics of most of the cases. So this is an average conditions, not as always the same conditions. Then the next level is stratosphere. Air temperature from this layer, stratosphere, the air temperature wanted to increase it. Why? Because we know in the stratosphere, the ozone is playing a major heating component. It has a major role in here, and within this layer, we can get the air temperature is increasing in a rate up to the 48 kilometers. Another important thing is if you send a balloon with a radio sound is a we'll also discuss at the later of this. Radio sound is a combination of some transmitter, thermometer, or many other things in a chips, and that particular type of instrument we do we do add with some balloons and a parachute, and then we just send it out. So when the balloon goes up, each of the time they send some signals to the ground, and in the ground we can record the pressure, we can record the temperature, each of them in here, and it goes up to ozone layer. After that it bursts out, and again it fall to the ground, and we collect it. This is a particular instrument, and which lasts long until the stratosphere. And it absorbs. A stratosphere is very much important, to which we will going to discuss in the ozone composition also, that it protects the ultraviolet ray from the sun, and that is a very harmful elements for our living components. Maximum ozone concentration is observed at 25 kilometers. So that is started half of the atmosphere, and yet the atmospheric air temperature reaches a maximum near 50 kilometer. Reasons for phenomena is dense. 50 kilometer is less dense than the 25 kilometer, and so the absorption of the intense solar energy at 50 kilometer raises the temperature of the FER molecules to a much greater degree. So this is the consequences of the atmosphere also. In your exam, sometimes it is a very important question, is a small question, is why a stratosphere is important. So you can write down this. Mesosphere started from 48 kilometers and last long 85 kilometers, and the boundary is near started just about 48 kilometers, upper 48 kilometers. And air at this stage is extremely thin. That means maximum air molecules is under the below of that things. And it said that 99% of the atmospheric mass is located below it. That means most of the air is under this layer. And even sometimes we can say the nitrogen, oxygen, oxygen percentage is also same in there, but we should also say that the concentration is different. Their ratio is same. The ratio is 78.08 of nitrogen, and oxygen is nearly 21%. That is same in here, but their concentration is different. Density is different because of the lower amount of the molecules. For example, they said that if you go for a long distance, for example, couple of kilometers, you can get a few amount of the amount of the molecules of particular type of gases. Another important things is if you go, pilots who fly above few kilometers of upper area, sometimes they will have lack of oxygen, because as we said, if you go to the top of the area, then your amount of the molecules will be minimum. And then pilots needs artificial amount of the oxygen in there. Not only pilots, but also who wanted to go there. So they needs extra type of facilities for oxygen. And if in the mesosphere, anyway, if the air pressure we can feel, if we wanted to feel the air pressure, then what will happen? For example, our blood cells will be burst out. That means in a condition with that atmospheric pressure, with minimum atmospheric pressure, with the normal temperature, our bodies inside the vein, the blood will be boiling up, and then they can be burst out, and because of the lower amount of the pressure. So in the ground, which we have 14.7 pound on our body, the weight, that created a good pressure on us. And if it is loses with the increasing of the height, then suddenly it might not be possible for our body to tackle it up. Of various reasons. One example is to boiling of the blood. There are many others way we can feel it. If you can go top of any mountains, for example, some people who wanted to climb up big mountains, they also sometimes feel the problem in that area. They also feel the problem of the oxygen. Even they wanted to cook in there, then that is also very tough, because within a very lower temperature that has been the water is boiling up, and with that type of boiling, your cooking is not been possible. So each of the layers which we started from the ground to the top of the layer, they gives us different types of notions. They gives us different types of characteristics. And again, in the mesosphere, the temperature is trying to lose with the increasing of the height, because there is no molecules in here, and the radiation is coming very easily to inside. And it is almost at the top of the 80 kilometers, it is almost 90 degree, minus 90 degrees centigrade. So in the troposphere, it goes minus. It stratosphere, it again, it increasing rate plus, and then again in the mesosphere it goes minus. After 85 kilometers, actually mesosphere remain, and oxygen molecules is more in there. More means not the concentration, more means other type compared to other type of gases, it is more in there, and that oxygen causes warming up. So in mesosphere, it again increases the temperature. Few atoms and molecules in the thermosphere, the absorption of a small amount of the energetic solar energy can cause a large increase in the air temperature. That means even the molecule is very small, number of the molecules is small, but that molecules percentage of that molecule, very small percentage, but that is enough to increase the temperature in that particular area. And low density of the thermosphere also means then if you have to travel to find out another molecules for a long distance. We called it mean free path of over 1 kilometer before colliding with another molecule. That means one molecule is in here, you have traveled to couple of kilometers, then find another molecules. And sometimes charged particles from the sun interact with the air molecules in these phases, and that produces aurora displaying, dazzling of aurora displaying in from this region. So after that region, we say exosphere, but there is no limit of that. We cannot say that after a couple of kilometers it can be started with, or maybe some 400, 500 kilometers, we don't know. So there is a difference between the distance from different areas of this world. So the upper limit, we can only say this is exosphere, but not the but we cannot say the exact distance from the Earth's surface. So this is all about the different layers depending on the height and composition. Now we can also divided it on the basis of the concentration. So lower parts, as I said, most of the gases remain in here. We can say this is homosphere, and about 80 kilometer from the Earth's surface, the most of the gases fairly they mixed up very well. We don't, again I should mention it that the molecule number is always being reduced if you go to the higher places, if you go to the above. But heterosphere also denotes that after 80 kilometers, the gas is not fairly constant. So they have different sets of their compositions, and they can be found differently. On the other hand, if you wanted to describe some electrically charged or particles, or some of the areas which is electrified, sometimes we said, we can divide another layer is ionosphere. Actually, it is not a layer, but this is a characteristics of certain areas. Sometimes we can found it. Upper atmosphere, where the fairly large concentration of ions and sometimes free electrons can exist. And these ions are atoms and molecules that have lost or gained some electrons. And so that they can also electrically charged when they can absorb a high amount of the energy to transfer to them by colliding energetic particles, or they can be get it from the sun rays. The lower region of the ionosphere is usually, normally it says 60 kilometer, and it can be varied depending on different other natures. So this is the way how we can divide it. Now it is very important, and most of the times we are very much interested about that. What would be the temperature if we go to the top of our surface? So again, we should maintain a process that until the stratosphere, the rate will be decreased at a rate of 6.5 degrees centigrade for every 1 kilometer. But it will be again increase from the stratosphere and all the way along. And vertical convection currents included primarily by the uneven heating of the layer. That means Earth's surface is uneven. So when the uneven heating happen on the top of the surface, it creates the variation of the temperature of the gases, so that the gases have different types of temperature, which is which is gained by different areas of the Earth's surface, and then they try to move. That means they try to move the air, move the gases, and these keep the air fairly well stirred. That means we expect the gases are very much well stirred up, and they move, and this is causes the convection currents. So now if you see this, you can understand it very well from our area of the top of the surface, Earth surface, until the tropopause, it has been decreased. You see it about some couple of minus 50 degree, 50 to 60 degree minus centigrade in the tropopause, and then again it increases until 50 kilometer. That means it is mesosphere, stratosphere, and mesosphere is started. And again, you see in the mesosphere, it has been increased due to presence of oxygen, much about the oxygen in here. So this is the way. On the other hand, if you go to these are the pressure, this is fairly constant, because if you go 10 meter height, then you will lose one millibar. Okay. So if you go up, then your millibar will be lost. And again, if it is until zero in a certain condition, 0.001 millibar at 60 kilometer. So these are the places, mesosphere, thermosphere, you don't have any weight acting on you of the air. You have no pressure actually on you. So you have weight, but you don't have any pressure on the top of your surface. So this is all about the recap. In the next class, we'll discuss about more details on different air particles and about other things. So now, if you have any question regarding this lecture, you can raise your voice. You can ask me.
Sir, in this slide, sir, aurora is mentioned, sir. How does the auroras are formed?
Aurora can be formed in a position that it can be aurora. What does aurora means? Aurora means a display of the light, and that light is coming from different layers. So so when ionized materials, that means in electrified condition, that particular type of electrically charged particles displays the light of the sun, and then through the other surface it come to us with different colors, and that especially colors which is coming from the electrically charged particles, it says aurora.
Okay, sir.
Any other questions related to this lecture? If you have, you can ask me. In the next class, we are going to discuss about more about the few of the gases, especially the variable gases. We'll discuss about more about that. And if you don't have any questions, may I ask Siam, who are absent today, can you give me the roll numbers?
Sir, there was 26 participants, sir. I have marked 2 of them, like sir Mumtahina and Moni was absent, sir. Sir, I can find other one.
Can you give me the roll numbers of them?
Sir, 19208105.
1905.
Ji, sir, 1905, 1947, 1948.
Okay. Okay. Thank you. And again, I should say, or I should again make you remember that always you should write down the source of my slides, because this is you will get these lecture videos because of these particular cases, but but this is not a lecture note. This is not a note for you for preparing the exam. This is only what I discuss according to my way to describe. Okay, So what you can do, you can write down the sources in here, and then I will give you the sources as in your other semesters, like in geography class. So I will give this book. Maybe I will upload it in your Google Classroom. Ahrens 2009. This is one of the book, and other books which is, for example, Miller 1976. This book I don't have, but you can have this book in a in our library. For example, these are Ahrens, this is Ahrens. So where does the different source I got, I wrote down in here, and you can get it easily and you can read from there for your exam. So keep in mind it, and you can ask me if you don't get the right information in that type of sources, then I will again check it up. So today's lecture, I took most of them from Miller 1976 and Ahrens 2009. So I will upload this on Ahrens 2009 in your Google Classroom, and then you will get the Miller 1976 from your library. Is it okay for you?
Yes, sir.
Okay. So may I ask Siam the next class on Monday, yeah? Monday same time?
Yes, sir. You can take, sir.
Okay, so normally I'll take the class. Normally I'll take that, but if there is some program that will come in the same time, then I will change the class. But normally
Okay, sir.
I will take the class on Monday and Thursday, same time.
Okay, sir.
Okay, so thank you joining me, and hopefully we'll come together again in the next class, same time, same on Monday next week.
Okay, sir.
Thank you.
Assalamu alaikum, sir.